In this session, we are going to solve Hackerack problem on week 1 exercise, pangrams. Pangram is a string that contains every letter of the alphabet. Given a sentence, determine whether it is a pangram in English alphabet. Ignore case. So we don't need to worry about if it is for case or lowercase. Return either pangram or not pangram as appropriate. Here is an example. The input string is the quick brown fox jumps over the lazy dog. The string contains all letters in English alphabet, so return pangram. Function description. Compute the function pangram in the editor below. We need to compute this. It should return string pangram if input string is a pangram, otherwise not. So basically it should return a string. And this is C++. We'll go to Go. Yeah, it returns string. Input format. A single line with string. So basically it reads string from the standard input. Here it reads. We don't need to implement it because it's already part of the main. It is implemented by HackerRank template. Constraints. The length of the string is between 0 and 10%. It's a very huge string. Each character is between A to Z and A to Z, both uppercase and lowercase with space. It's basically printable characters in the ASCII table. Sample input. Sample input 0. We promptly judge antique ivory buckles for the next prize. Sample output, it's a paragraph. So it looks like this sentence that we just read, heard out now, has all the English alphabets. Sample explanation. All the letters of the alphabet are present in this string. That's correct. Sample input 1. We properly judged antique ivory buckles for the price. This next is skipped. So likely NEXT is missing. So it's not a paragraph. Sample explanation. The string lacks X. X is missing. That's it. Now how we are going to approach this problem is something that we will learn in our dry run shortly. Sentences in Golang is represented in form of a string. Here we have a input string. Quick brown fox jumps over the lazy dog. So we have each word in the string separated by a space. If we were to refer this sentence in form of a string, first character starts at index 0 and the last character is at len of string minus. Problem, we are going to make use of Schmidt. It's going to hold a key values too. So the key here is character key. Value is going to be the frequency or number of times the character occurs in the string. Before we discuss about the approach for solving this problem, let us understand pangram once more. Pangram is a sentence that has all the characters of the English alphabets A through Z at least showing once. So this can be 2 times. A character can be shown 2 times. However, it has to be at least once. So now we will traverse over the input string starting at index 0. So we are going to have T, and that's going to be updated with frequency count 1. Next, F. That's going to be updated with frequency count 1. Likewise, E, Q. Each character is going to be updated with the frequency count as the and once the string is processed completely, the length of the hash map is computed. If the length of the hash map is 26, then it is a graph. Otherwise, we say The string is not pangram. So with this visual background, let us jump into coding. So before we start coding, I'm going to reduce the window size here and minimize the functions that is not of relevance to us now. Just focus on pangram. The function pangram takes an input string and returns a string. The output string indicates if the input string is pangram or not. So let us start coding here. So I'm going to create a hash map as we had discussed during our visual walkthrough. So let's say create a hash map, and that's going to be frequency map. So I'm just going to say frequency map colon equal to make map of input string and the integer value, which is going to be count. So here going to be root. Now we are going to convert the input string to lowercase. We need to ignore case as we had seen here, ignore case. Next, we iterate over the input string, pull out each character from the input string, insert it into the hash map along with the frequency count update. So iterate over the input string. Yes. For pH, and there's going to be a range loop. If CH is greater than or equal to A and CH is lesser than or equal to B, then we update frequency map. Frequency map of CH plus plus. Once when we are done with this loop, we are done with processing the input string. So now we are good to verify the length of the hash map, and the length of hash map is 26, which is equal to total number of characters in English alphabets. Then we return otherwise return not. So we don't need this else statement here. We simply say not pangram when we are just out of this if loop. Okay, we are done with the implementation. Time to run this. It's processing and it will take a while. Yeah, there are two test cases as we had walked through in our description, and both of them have passed. The first one is a pangram, while the second one is not a pangram because X is missing. Let's subject this to few more test cases that HackerRank has provided us. Let me submit it. There are 8 test cases, and all of them turned out to be green, which means it has passed all the test cases. So we are done with implementing the function for finding if input string is pangram or not. That's it.